Hello everyone, welcome back to another video. So today we want to talk all about testing. So the thing to note about testing, the first thing I'll tell you about testing is that there is no general test strategy. So when we're testing a piece of software, we have some goals that we want to aim for, but how we get there is really up to us and really different from situation to situation. So here, all I'm really going to talk about is kind of the general view of testing, maybe what types of tests there are. And even then, there are different names given in different companies that you work for. So take this as an overview of concepts and not necessarily here's an algorithm to complete your testing. I'm not necessarily going to tell you how to test. I'm going to sprinkle in some tools now and then, but mostly this is to give you an overview to talk about what software testing actually is. All right, so let's dive right into it. The first thing we want to talk about is this idea of V&V. So V&V stands for verification and validation. So verification is, are we building the product right? So this is really just, something that sounds good, and it just says that your software should be free of defects, right? So this is it performs correctly and it's intended to find areas where the program does not conform to its specification. So the specification that we wrote down, does it conform to that specification? Validation, on the other hand, is are we building the right product? So the software should do what the user requires. So does it perform correctly when the given data matches its expected use? Right. So a successful validation would mean that it actually meets the user's requirements, right? So in reality, does it actually meet the user's requirements? Not what we write down, not what we wrote down, but actually does it meet the user specifications? All right. So there's this nice quote from Dijkstra, the from Dijkstra's algorithm, who says program testing can be used to show the presence of bugs, but never to show the absence. And this is really true. And you can write as many tests as you want, but there is no guarantee that there's no bugs in your software. So just take a look at, your favorite piece of software and the ones that you've been using. There are always bugs that you can find. There are always times that the system crashes. And so, no matter how much testing we do, there's always going to be instances where we find bugs in our software. So, this also leads to another interesting point, which is the idea that there's no validation process. There's no process to say, okay, I've fully covered all of the test cases, and now I'm sure 100% that my application is going to be free of bugs. This just doesn't exist. So the way that we get there is going to be very different, right? Depending on situation to situation. So that tells you that there's no like exact process to this. All right. So I'm going to introduce two terms and I'm going to focus mostly this talk about software testing, which is executing the system and observing its behavior. And there are a lot of software tests types out there, and we're going to get into each one. But I actually want to start with software inspection. So software inspection is probably the most kind of offline type of test where we analyze the system's code, the design, the or tests to look for any defects that might come up. So this is kind of like a visual inspection or a walkthrough of your software. So the good thing about inspections you can see here is that we're inspecting every aspect of our software development, whereas testing can only cover certain parts that pertain to code. So our program can be tested. Maybe system prototypes that we build in the very beginning to answer specific questions that we might have, those can be tested. But other than that, inspections can kind of fill in the gaps where we're missing from the requirements all the way down to the programs. So some advantages of just pure inspection where we do a walkthrough of our application. So obviously, we can test for defects plus analyze any code quality that we have. So any portability issues, any maintainability issues, any design issues that we have in our UML, this is an inspection issue. So these things typically pertain to things like code reviews, right? So I can review your code to see if this is efficient or it's maintainable and all of that good stuff. And we can consider all possible paths through the code as well. So this is, a walkthrough testing. We may not be able to exercise all of the different paths through your code. And so the good thing about this also is that incomplete versions of the software can also be inspected and could be walked through. Obviously, some disadvantages of this would be that certain characteristics of non-functional requirements cannot be directly tested in this way. So things like performance or usability. If we have an incomplete version of a software, if we only have code that's half working or we only have a design, then this is going to be a little bit more difficult in terms of analyzing the performance and how it actually behaves in the real world. Usually, inspection is done by a separate team, so it's not really recommended for small dev companies. We usually require some sort of manager type, an overseer for inspection, just because it does require a little bit of experience in order to kind of see what to inspect and how to go about these things. All right, so let's dive a little bit deeper and talk a little bit about manual and automated testing. You've probably heard of these terms referred to from time to time for testing. So starting with manual testing. So as the name suggests, manual testing is testing without the use of a tool or a script. So mostly this involves human intervention, and it's usually reserved for smaller projects, ones without high levels of integration, and it tries to cover each scenario or use case. So this is basically a focus on the requirements, and it's usually applied to exploratory testing or usability testing, but of course, manual testing could actually apply to a whole range of different types of tests. So just to get into it a little bit, when I talk about exploratory testing, I'm really talking about an approach to testing that is focused more on the creativity of the tester. So it's unscripted. So again, you could probably imagine this takes a little bit more of some experience from the tester themselves. And it's really just as the name suggests, to explore the application and to learn about certain workflows. So there are you at the same time that you're testing, you're learning about the application and you're also thinking about design, but also the, the the actual application and thinking about use case scenarios that you can test. So it draws on the tester knowing the domain very well, right? So obviously they have to know what is actually the requirement of the user, and they draw their test cases from that knowledge, from that domain knowledge. All right. Whereas usability testing, I'll get into that a little bit deeper as well, a little bit later on, is the idea of evaluating how easy or user friendly a software application or website or a product actually is. So usually this involves real users. So the real users would be given a scenario. So you're testing the usability of, let's say, Amazon, right? The shopping cart of Amazon. And so an objective would be placed on that to evaluate the ease of use for the checkout, let's say, right? And we would have some participants, maybe 20 of them, that we would observe how they're interacting with the application. And we would tell them, add items to the cart and then go to the checkout and then go to the shipping and payment information. This is a very simple example, of course. And then we would observe how their interaction is. Are they making any errors? Do they have to press the back button at any point? Right. So those all go into usability testing. And we basically record how many errors are they making and whether or not this is a passing test based on our criteria. So you can see this is a very manual process, takes a lot of human intervention and interaction with the application itself. All right, the goals of manual testing is to uncover bugs or defects and more to understand the client's requirements, right? So to see if we've actually achieved the client's requirements. All right. So in manual testing, here are generally the tests that the steps that we would follow for this type of test. So we would first prepare a test plan. So a test plan could involve things like a scenario. I'll show you in the next slide what that means. What are the objectives of this test? So we want to test for usability, right? We want to see if this checkout is usable for type of users. We want to provide a schedule. So how long is this test going to take? When is it going to happen? Is it time specific? What environment are we running it on? So I'm going to run it in a simulation of the production environment and so forth, right? What kind of tools are we using, right, for this test? So we write out a full plan to describe how we're going to execute this plan, this test. And so we prepare the test cases. So we prepare the environment, we prepare the tools, we mock anything we need to mock, we simulate anything we need to simulate, and then we follow the steps outlined in the test case. I'll show you that in the next in the next part here. And then we report the defects. Okay, so reporting defects involves tracking them and managing the defects as well. So there are softwares out there that allow us to be able to manage any defects that come up, as well as to see if there are any bug fixes. And then this goes along with regression tests as well. And again, I'll talk about regression tests a little bit later on in this video, but a regression test is basically a focused test on things that we have changed. So whenever there is a bug fix or there's some code that has specifically been changed, I'm going to write some tests to target that change. So in our last example, let's say that I found that users found it really unusable, right? The shopping cart was very unusable because some of the wording was very unclear on the shipping. So I might change some of the wording. I might even change the workflow, and I write some tests to target that thing. So maybe I will write another usability test or somewhere along those lines, and and check the changes that has occurred. All right, so here is the documentation. Here's an example of a report. So for example, I might say the testing scenario is that I want to test the login functionality on a successful login or an unsuccessful login or stuff like that. So you can see that scenarios could actually derive many test cases, right? So the test case that you're looking at here is I want to verify that a user can successfully log in with valid credentials, but we could have invalid credentials as well, right? So the test steps that we would take would be open up the Google Chrome, right? Navigate to myapp/login, the login endpoint, type in a valid username and a valid password, and then click the login button. So what I expect to see from that would be that a user would be redirected to the dashboard or the home page. And the user should see a welcome message with their username displayed on the dashboard, and then there should be no error messages. Okay, what's the actual result? So we're going to click through, we're going to record everything that we see in this test, and we're going to find that we are redirected to the dashboard and there is a welcome message with our username on it, and there are no unexpected behavior. Now, unexpected behavior could be things that are extensions to this use case as well, right? So I could record that, oh, I observed something that I wasn't expecting to see, right? So maybe there was a display message, but I don't know, maybe it was somewhere in the corner that I didn't expect to see in my expected results. So I would note these behaviors and then I would track them by doing regression tests that follow up on any unexpected behaviors. On the other hand, if everything passes, if everything is to expected behaviors, then this would be a passing test and we would document that as well. Now, of course, there are a lot of things that we can throw into this, right? So, for example, seeing the display message, we might include some screenshots that we expect as results to just show the tester that this is what we plan to see, right? So, there are a lot of variations and a lot of flexibility in how we write these reports, and different companies will definitely do it at different with different priorities in mind. Okay, so let's get into automated testing. So you'll notice that the very last thing we talked about, everything was very manual. We had step-by-step instructions to the tester on how to do things and what to see as a result and so forth, right? So all of these are manual processes where the human has to actually go through and eh, and observe the results. Now, there's a good thing about this is because that has a lot of subjectiveness to it, right? So we have like user feelings or user how the user is able to describe what they're seeing. In automated tests, this is slightly different. We're testing with automated software. Okay, so examples of this would be like JUnit or Selenium, but there are many, many different tools out there. There are different tools for different types of tests. So JUnit, for example, would be used for something like a unit test or an integration test, things I'll get into a little bit later. Selenium would be things like automated browser tests. So it would automate the functionality testing. So certain functional testing, the consistency of web pages across different browsers, end-to-end workflows that we want to test for correctness. We could use software like Selenium to help us with something like that. So it could be part of an automated manual process as well. So it could be derived from a manual process, but it doesn't necessarily have to be. It's used in development testing, load testing, performance testing, and stress testing, among others. And these are just some examples that I throw out there. Basically, how we know that something can be automated is if there are tests that needs to be run many, many times and under many, many different conditions, right? Then we might want to think about that. We want to test this automatically, or we might want to write an automated test for this purpose. So the goals for automated testing would be obviously to reduce the amount of work of manual tests, but also we want to be able to put it as part of a production pipeline that we don't have to care about having to run these manual tests every time we deploy something, right? So it will actually give us more confidence in terms of our application working because it's passed all of these automated tests. So what do I mean by this automated test or continuous integration pipeline? So most automation tests are integrated into some sort of continuous integration pipeline. Okay, so an example of this would be render.com. So when you push something onto render and you push something onto the main branch, render will automatically see that and it will automatically pull that code and it will install it on the production environment. Okay, so production environment being render. And of course, render is a tool that allows us to be able to have a production environment on the web that we have a URL that this simulates the actual software, or even it could be an actual software, right? That's there. But let's say we want to take that idea and we want to develop our own integration pipeline. And this is just one example of what you might have. So you might have a monitor to changes to GitHub in the main branch. And when there's a change to the main branch, I'm going to pull the changes and it's going to build that software. So this could be a Spring Boot application. It could be some sort of other application. It's going to build it. And on that software, it's going to run some automated unit tests and integration tests. Perhaps it's going to run some automated end-to-end tests as well, and then run some static code analysis to see if there are any security holes or vulnerabilities in your application. And then it's going to deploy to the actual production environment. Okay. Now, again, depending on the company, depending on the size of the project, how many teams there are, and just basically the resources that you have at hand, this automation, this continuation integration might be shorter. It might involve less steps or even more steps, depending on the environment that you're working in. Okay, so let's talk about the different types of tests that are out there. Now, I'm going to throw a lot out at you, but again, as the theme that I've been getting into in this whole topic is that these tests, depending on the company that you're working for, they will use different names to describe different types of tests. So what I want you to understand in this section is that these are the techniques that we would use in order to do testing. These are the areas or focuses that we would have for testing. The names are not that important, although, there are some that are pretty standard across companies, but generally I've seen same type of test be called different things from company to company. So first, let's start with functional testing. Okay, so functional testing is to be contrasted with non-functional testing, which we'll get into a little bit later. But as we know, functional tests or sorry, functional requirements are things that test functionality in your application. So what are functional tests? They verify the software functions to be working as expected according to the requirements or the specifications. So these are the things that we wrote down in our specification document. So we want to write tests that are testing against those things and making sure that those things are actually working. So we want to focus on what the system does, and we want to make sure that it's actually working correctly, again, according to our specification. So this may involve things like checking interfaces, right? It might be checking APIs. It might be checking like large parts of our system, integrations of our system, maybe our databases and other parts of the software that allows us to ensure that these requirements are now satisfied. Okay, so let's dive right into it. What are the different types of functional testing? What types of functional testing are there? So here are just a few examples, and I'm sure there are many out there that I've left out, but some examples would be unit testing. So by far, you will be doing the most unit testing for any project that you have. So this is the most type of testing that we're going to do. And the unit test is testing on individual components. So the smallest denomination of code. So usually this is methods or or to ensure that certain classes work in isolation. So we try as much as possible to isolate a class or a function in order to test that functionality. So I'll talk a little bit more about that in the next few slides. Maybe an example of a unit test would be testing a function that, I don't know, calculates the sum of two numbers, right? So I'm going to give some test cases. 2 plus 3, all right, does it actually give me 5? 0 plus 0, I would probably say that would be an edge case. Does it actually give me 0? All right, so there are certain things that we have to think about in terms of unit testing, and I'm going to go into a little bit more detail about that in the next few slides about how we can choose test cases, what are some parameters that we need to think about, and so forth. All right, the second one is integration testing. So integration testing is the interaction between integrated units or components in your application. So usually integrations are done incrementally. So we start with a unit test and we find that the unit test for this thing is working. And so what's the next step up from that? Oh, I want to integrate another component into it, right? So with these two things, the communication, can I integrate them and be happy with how they're talking with each other? Okay. Now, at this point, I want to just take a step back and I want you to notice that the the general kind of language I'm using here, right? I'm struggling to, I'm not struggling, but I'm tempted not to go into too much detail about this, just because integration tests as an idea can be done in many ways, right? And with many factors into it. So as an example, maybe of integration testing, it could be integrating a login module with a user database, right? So not only testing the login endpoints, but to integrate this with an actual user database. So I have some actual user data with some passwords in there, and I want to go to a user module and I want to test the endpoint, but I also want to test if the endpoint is calling this database properly and retrieving the user passwords correctly to validate my login. Right. So that would be an example of an integration test because we have two components that we're integrating together. Right. Number three, system testing. So system testing is a testing the complete system. And usually this is done in a simulated environment, not in production, but a simulated production environment. So a system test is another step up from integration. So as we start integrating more and more components together, eventually we'll have integrated the whole system together. And at that point, we can start testing the system in terms of the input and the output, right? So for example, going back to Amazon, right? So an example of a system test could be that I'm testing this Amazon website or Amazon-like website to ensure all the functionalities, like searching the product, like buying the product and checking out, payments, everything is working correctly, right? So that would be an example of a system test. And you can see that we're getting closer and closer to the requirements, right? To actually getting the full requirements down. All right. The next step up from this would be a acceptance testing. So this is often called a user test or user acceptance test as well. So a user acceptance test is where we use real world users, real world data in order to see if this fits their needs. Right. So we can have a system test that tests against the requirements, but does it actually work in reality? Right. So does it actually work in the real world? So this is a validation of the actual software done by real users. So an example of this would be to take the real user's data and to put it into our test to simulate whether in the real world this is going to give us real results back in certain workflows. All right, next, there may be times that we might need to do bug fixes or changes to our code. So when we do that, we are doing regression testing, which is testing with new code in mind. Okay, so new code means that any changes we've made, this could have been a branch that was branched off, or this was, a hot fix or a bug fix or anything like that. Although hot fixes, I'll save for a little bit later on. So maybe a bug fix, a full-on bug fix then, and I want to write some tests to target specifically that bug that I have patched up. So as an example of a regression testing, perhaps we've added some functionality and maybe in response to user testing. And then we want to test this new feature. So regression tests are run to ensure that there are no other parts of the application that are going to be affected or broken because of this new change. And again, I'm keeping this very vague because depending on the situation, there might be many things that we need to think about. in terms of a regression test. I've changed this part of the code. Which other part do I now need to test as well to ensure that this new code is working? Smoke testing. So smoke testing is a test for only for critical functionality. So I would say it's a subset of necessary test cases. It covers the most important functionalities of your software. Okay, so this is to ensure that critical functionalities are working correctly, and you can say that this is analogous to like very early parts of agile development where you say, oh, I'm going to prioritize which requirements are more important. So a smoke test would typically target those types of requirements. All right, so smoke tests are usually designed for, or typical smoke tests would be things like login, right? A simple navigation. Maybe like if your application is centered towards data entry, right? So if that's the most important part of your application, then I want to write some smoke tests for data entry, right? So it's a focus on the most critical parts. All right, sanity testing. So sanity testing is a small regression test for minor changes. So that's what I was saying about hotfix earlier. So a sanity test would test things like, very small changes or maybe small bug fixes. It's targeting those types of changes just to see if this bug fix has altered anything else to be running properly. All right. So in terms of strategies, right, you've probably heard of these terms, black box testing and white box testing. And the difference between a black box and white box testing is really just how much knowledge do we have of the internal code structure. So black box testing is testing without the knowledge of internal code. Okay, so it's just testing inputs, outputs, right? So a black box test might be testing, again, going back to an example of a login, might be I'm going to enter a combination of usernames and passwords and see if the behavior is as we expect. That would be a black box test because we never test the internals. We don't really care how it's implemented. Whereas a white box test is targeting the internal logic, maybe of an algorithm or things like that. So we might test, for example, a searching algorithm that we have in our Amazon site, right? We might test the steps that it actually takes to get the search results back to the user. So that would be an example of a white box test. Finally, here we have interface testing, which is testing interactions between software components. So this is really just to ensure that your software components, APIs, and interfaces are working properly. So for example, I'm testing the API endpoints to verify that the data is correctly sent between the client and the server, right? So this would be an interface test. And again, testing on the functionality of the application. All right. So as I said, there's probably a lot more that I haven't mentioned here, but these are probably the ones that you'll hear the most, uh, you know, depending on what company you work for and the circles that you're in. All right. So let's dive into unit testing a little bit deeper and talk a little bit about the process. So we are testing individual components in isolation. So they're isolated parts of our application. So this might be in terms of a function or method or classes with its specific attributes or methods, right? So the smallest component in your application. So a complete test coverage of the class would involve testing different states of a class and testing all of its methods. Now, again, it's really difficult to measure test coverage, right? The coverage of a test. But in terms of a class, we can have kind of a structured approach where we try to imagine when this class is operational, any objects of this class, what methods would be called in what circumstances, right? So when would we call this method and what states could this class be in? So when we talk about a state of a class, we're really talking about like what are the fields associated with this class, right? So what fields are filled in, right? That would determine the state of a class. So in terms of unit testing, we talked a little bit about this earlier, but how do we determine the test cases, right? So how do we check for test cases? So I'm going to test for when these test cases are used correctly or when our application is used correctly, and also when no defects are under extreme or invalid input. So these are all situations that we would look for. All right, so what would be some strategies? So again, there are many, many strategies out there, and this is where we can kind of exercise our creativity a little bit, right? So there's no saying, oh, you have to follow this, right, for unit testing, or you have to follow this for regression testing and so forth, right? So how we choose our test cases reflects our personality and also reflects like how we are, like how we view the application. Okay, so that said, what are some strategies for test generation? So number one, this is probably the most obvious one, test some boundary values, right? So boundary values, edge cases, right? So things like zero, things like the largest integer, things like the smallest integer, right? So do these things actually work? Do they give the expected results back? Okay, so for example, I might say that boundary case for a function accepts a number between 1 and 100. Okay, I might test things like 1. I might test things like 0, so things that are slightly out of the boundary. I might test 100 as a boundary, and so on. Okay. Another strategy would be that I would have order based. Okay, so order based input. So usually this is referring to things like a structures that we have in programming, things like arrays or lists or things like that, right? Or sets, right? So in which order? Well, in the case of a set, we would not have order, but you can see where we're going here. But sorted order, unsorted order, reversed order, right? So different types of orders, that might be a strategy for test case generation. Another one would be a partition. So a partition would be to divide our data, our test cases, up by equivalence relations. So an equivalence relation would be a case where all of the objects belong in a partition, right? Belong together as a group, as a set, right? So as an example of this, I might say, let's say I'm building a multiply function. Okay, so a multiply function, I might test one equivalence relation where we have both positive numbers. Okay, so if I'm multiplying two positive numbers together, then what do I get? I get a positive number, right? One negative and one positive. What do I get? I get a negative number, right? And then finally, two negative numbers will give a positive number, right? So I test all of these partitions to make sure that those are actually functioning properly as well. All right, so I might test for state transitions. So state transitions are usually focused on testing state oriented applications. So if you have a state model associated with your application, I can test along that as well. So these are useful for state machines or modules that have particular workflows. So I'm testing different states in the app. So for example, if I was writing a ATM machine, right? So an ATM machine might have state transitions for waiting for a card to be inserted, right? So let's say we have a state that is waiting for card. Okay, let's test that condition. I have an inserting of the card. Okay, that's another condition. Entering a PIN, that's another state, right? So the transitions between these states, and then of course selecting an account, and then processing the money and so forth, right? So you can imagine all the different states that the ATM can be in, and so we test on those states and the transitions between those states. Okay. All right. So what else? We have guideline-based testing. So guideline-based testing is sometimes referred to as error guessing testing. So these are generate some error cases, right? So think about all the bad things you can do to this application or to this unit that you're testing. So maybe generate all of the exceptions that are in your class, right? All the possible exceptions I can run into. So maybe one test for each exception, test for buffer overflows, test for large numbers, right? And small numbers and so forth, right? Null inputs. So those are all examples of error cases that you might run into that you write tests for. Okay. You might write tests for historical data. Now, this one might be less pertinent for unit testing, just because unit testing, there might not be historical data for certain classes, but generate test data from past bug reports, right? So in the past, there have been these bugs that have been noticed in the application. So use this historical data in order to generate your test your test data for this round of testing. Complex logic. So this is really just white box testing of the internal logic. So so especially if you have very elaborate algorithms that you're processing, it might be a good idea to do a couple of assertions on parts of that algorithm, right? So assert that, for example, n leads to n plus one, right? In the case of induction or something like that, right? So if you have, complex logic associated with searching and so forth, this might be a good opportunity to use logic-based strategies for test generation. All right, so acceptance testing. This is also called user acceptance testing, UAT. This is where the customer tests a system to decide whether or not it's ready for deployment, and usually it is on user-centered data. So there are two main types we'll talk about here, alpha testing as well as beta testing. Alpha testing and beta testing could both be manual testing as well as automated testing. So we could actually write automated versions of these tests, but usually we look at it more as manual testing. So for example, we have in alpha testing, user comes into our developer site and actually is working in our environment to try to come up with some bugs. And usually we're at a stage in development where we are not very confident that there are no bugs. Usually there are big bugs that are found in alpha testing. But the good thing about alpha testing is that they can get to the bugs really quickly, and there's immediate feedback to the developers, and usually there are immediate results. And this is an internal process where the people who are doing the alpha testing are usually paid. They're usually part of the development team even. Whereas in beta testing, we have kind of a release, a type of release to a subset of the general public, and they do the testing. Now, in this case, the bugs that are found are usually a little bit smaller, right? As they're usually not as extreme, and they are usually testers that are not paid, right? So they're usually end users, but they're not paid. And usually you have a larger subset of these testers. And this is an external process where we have a larger group of users. All right, so this all leads up to our V model. So I'm not going to get into this in too much detail. This is just a model for development to kind of align the tests with each part of the software development cycle. So in user requirements engineering, for example, we would be looking at the associating acceptance tests, right? Because after all, these are user requirements, right? They know what the requirements are. This is what they want to test. System requirements are going to be system testing, right? So it's testing on a simulated environment against the technical requirements of the software. We have the architecture engineering, which usually leads to integration testing, the different components. If you remember that, we talked about that. In terms of design, this is a subsystem integration level testing, and then we have where we have the coding and our individual classes are unit tested for all of their methods and fields and so forth. All right, finally, let's talk about non-functional testing as a final subsection of this topic. And so when we talk about non-functional testing, this usually refers to aspects of the software application that don't relate to specific behaviors, right? So as we talked about in terms of non-functional requirements, these are things that are architectural, right? So they refer to architecture decisions. So they don't relate to specific functionalities, but if something goes wrong here, then it's super noticeable, right? So they usually are related to things like performance, usability, safety, and security, right? Things that we usually don't think about unless something goes wrong. So we'll give a few examples of this in the next slide. But non-functional testing is crucial because we want to make sure that it meets certain standards to be released to the user, right? So we want to be able to make sure that the environment that is sitting on and when we push it into production, that there are no issues pertaining to the overall experience of this application. So not the functionality, but the actual architecture, the actual behavior of the software. Does it impact anything on that level? All right, so let's take a look at several types of non-functional testing. So just like in functional testing, I'm going to give you a few examples. There's probably a lot more that are used in practice, and the names that are attributed to these may differ depending on where you work and so forth. But let's first take a look at this type of performance testing. So as the name suggests, we're looking at the performance of our application. So examples of performance testing might be load testing, right? So load testing is testing a system under expected load conditions. We deploy our application into production and we check under expected load conditions, expected number of concurrent users. Does it actually respond in a set amount of time, in a predetermined measurable time? Stress testing, on the other hand, is under extreme conditions. So in stress testing, we determine the system's behavior under extreme or peak load conditions. So usually what we do is we test how a server handles like a sudden spike in user traffic, right? So suddenly there are 1,000 concurrent users. Can it handle this in a manageable amount of time or expected amount of time? And we would have measurements to make sure that this test would pass. A related idea of this would be volume testing, where we handle large volumes of data, right? So for example, if I have a database that is, many lines long, right? A couple million lines long, does it handle this type of traffic as well, or this type of data storage as well? There's a scalability testing, which is checks for the system's ability to scale up or scale down based on demand, right? So it's testing how an application performs when additional resources may be needed, or maybe like we fluctuate the amount of incoming requests and the type of requests and so on, right? So this all tests about scalability of our software. By the way, whenever there's a scalability problem, they it would be a performance issue for some users, but not for others, right? So we would see in a scalability problem that sometimes the requests are answered or responses are coming back really quickly, but in other times they are not, right? So that would suggest a scalability problem. All right. In terms of security testing or vulnerability, we're checking for vulnerability and threats. So any risk to our software, any security issues, or even safety issues pertaining to the user's data, that is what we're testing in security testing. So for example, we might be testing for a SQL injection or a cross-site scripting. There's a whole line of vulnerabilities that are published every year by OWASP. So I will link that in the description below if you're interested in taking a look at some of these. They change from year to year, but for the most part, security vulnerabilities are, pretty standard, right? So there are ways into your application. I'm speaking mostly for web applications. They are, through the different holes that you have in your application, right? So I'll leave a link there so that you can look at the different types of vulnerabilities that we have for security. All right, next we have usability testing, which assesses how user-friendly it is, how intuitive the software is to use, how often does a user going through a particular workflow make mistakes or press the back button. So we talked about that a little bit earlier, but an example of a usability test might be testing a navigation and a layout of our website, and to ensure that users can quickly find what they're looking for, right? And not, again, press the back button. That's a big thing. Reliability testing ensures that our software is consistent over time. So an example of this might be testing a server application to verify that it can run continuously without error, without, any crashes over a set period of time under normal usage. Right. So that would be a reliability test. And usually it spans a little bit more time. All right. Next, we have a compatibility testing. Compatibility testing refers to verification of the software that works across different browsers, different operating systems, different devices, basically different platforms that it will be used on. So I mentioned Selenium a little bit earlier. That would be a compatibility test if we were to test our application on different browsers, for example. That would be an example of a compatibility test. We also have compliance tests. So compliance testing ensures that the software meets regulatory and legal requirements specific to our domain. So this takes specific types of domain knowledge, and oftentimes this is handled by another department, so that we might have a legal department that is doing compliance testing for our application. So for example, if we were writing an application for healthcare, right? So healthcare may have a lot of government regulations pertaining to patient privacy, or the way that we conduct certain workflows, where the data has to be kept, and so forth, right? So a legal department would know about all of these compliance issues, and they would test against those to see if we've to see if we're violating anything along those lines. Okay, and finally, we have recovery testing, which is, as the name suggests, the system's ability to recover from a crash. So, for example, let's say our database system goes down. Are we able to recover that data and make sure that all of the data that we have retrieved is representative of the real world, is consistent with the real world, and still doesn't affect our application being run successfully? All right, so all of these, if you could go back and kind of review some of these, are all talking about non-functional requirements, right? So they could be extenuating circumstances, or they could be extreme circumstances, but they ultimately are talking about the architecture, right? So they are a reflection of the architecture. So I would probably say this type of testing is more oriented towards understanding the architecture of your application. Okay, so that's really all I have for this unit. If you have any questions, please feel free to email me. But otherwise, I hope you learned something here, and I'll thank you for watching, and I'll see you in the next video.